Right. A piece of steel wool has a mass of 0.5972. And it's completely dissolved in sulfuric acid so that all of the iron will form Fe2+. Okay, remember that's steel wool. Now the resulting solution is diluted to 100 mils. So we end up with 100 mils, okay, of Fe2+ solution. And then from that, we are taking 25 mil aliquots of for our actual titration. When we titrated it against our permanganate, okay, so that's Fe2+. And this is my permanganate in the burette. It told me that we used 27.80 mils. Now from this we're going to determine the iron content. So this has already been standardized. This, oh, hang on. No, it's the sulfide dichromate in this example. Yep, so this is already standardized. We can't use this to start with. Why not? Why can't we use that mass? It's not pure. Okay, if I calculate with that, then it's defeating the purpose of the whole titration, because I'm saying that that's 100% pure. Okay, so I have to ignore that at the moment because that's steel wool, not iron. Well, not pure iron. Right, so our calculations have to go through the acidified dichromate. We know that this has a concentration of 0.01572. So we are going to determine the moles. It's N equals C dot V, doesn't it? And it's going to equal the concentration times the volume of the dichromate. And you end up with 0.0004369 moles. What are we doing?
Oh, sorry. Do we actually have to do step 1 for this where they write out the half equations?
You need a balanced equation. So whether we need the half equations or not, yeah, depending on how the question is set out. But I'm just going to use their equation that's already balanced there for me. And I can look then at the mole ratio. Which according to the equation is what? What's the mole ratio? Yep. So if it's 1 to 6 here, what do I do to this to work out the moles of iron? Sorry? Multiply by 6. Now I know the moles. There's a couple of different ways we can work from here. But this is the moles in 25 mils. Remember? That's what we were actually titrating. But we're going to need to know the moles in the whole sample. And so you can see that in the booklet that that's represented as multiplying 100 divided by 25 is 4. So you could write it in as multiplying by 100 over 25, or you could write it as multiplying by 4. It doesn't really matter. So we want now we know how much we have in the whole original sample, we can work out the mass. We know how many moles we have, so our sample mass will equal moles times molar mass, which in this case is atomic mass. So our mass of iron will equal this many moles, multiplied by the atomic mass of iron, 55.85, 0.5857 grams. And it's at this point now that we need to use this impure value, because we want to get our percent purity of the iron, 0.5857 divided by 0.5972 times 100 equals 98.077. Why does it need to be to 4 sig figs? Yeah, we're given 4 sig figs for everything in the question. So our answer has to be to 4 sig figs. And this is the sort of value that we would expect. Okay, now I did skip the balancing because we've done a bit of balancing in our examples already, but you must remember that this is a crucial step where you're referring to the mole ratio in the balanced equation. Alright, so hopefully that also gets you thinking again about calculating quantities.
So would that be the second experiment that we do of the primary standard one?
Yes, yeah, that's right. So you standardise your permanganate. This one's dichromate. It's a similar one, but it's not identical. But yes, this would be the second experiment after you've standardised the permanganate. Any other questions?